My name is Bhupinder Singh, and I work in the Office of Fuel Cycle Technologies within NE, and that, of course, stands for the Office of Nuclear Energy. The technical point of contact for this IRP is David Pointer. He is from the National Laboratory, Oak Ridge National Laboratory. And so on the next slide, we have the goals listed for this IRP. Over the past decade, NE has provided significant funds for development of advanced modeling and simulation capabilities for nuclear energy systems. Now, we've been making these investments through a number of programs, which include NEAMS, COSL, and the Fuel Cycle Research and Development Program, which is funded under the office I work for, which is the Office of Fuel Cycle Technologies. So the first goal of this IRP is to make tangible progress towards validation of some of these modeling and simulation tools that model multiphysics phenomena with high fidelity. So now in my office, which is the Office of Fuel Cycle Technologies again, one of the top priorities is research on development of accident-tolerant fuels for the current fleet of light water reactors. Therefore, we're very much interested in validating the models for phenomena that govern the behavior of accident-tolerant fuels in postulated accident conditions. But I've only listed this as an example on this slide because this example is not intended to limit the scope of the work that may be proposed under this IRP, as long as the IRP responds to the scope of work, the goals and objectives that I'm going to go through, then that's appropriate and you can submit that. Validation of multiphysics codes requires special considerations because the traditional methods of coupling and validating single physics codes are not adequate. Therefore, a second goal of this IRP is to establish new approaches to validation experiment development, which recognize these special requirements and provide adequate data resolution as well as appropriately characterize uncertainties. This goal includes development of methods to assess the impact of individual phenomena on integral data for multiphysics simulation. So on the next slide, I have listed the objectives. We are seeking to develop a state-of-the-art experimental multiphysics validation benchmark that models an application of high importance and demonstrates high-fidelity experimental methods as well as enhances approaches for validation and uncertainty quantification. This IRP also supports the use and adoption of the modeling and simulation tools that are being sponsored and funded by our office by expanding their validated regimes. It also supports the efforts of the DOE Nuclear Energy Knowledge and Validation Center to establish methods and guidelines for validation and uncertainty quantification, and also supports our collaborations with OECD NEA in this area. Now on the scope, this slide summarizes the scope of the IRP, and which includes plan, design, and conduct an experiment that can serve as a benchmark for critically assessing the results predicted by a multiphysics simulation code for a nuclear energy system, document the methods for designing the experiment, including those for collection of data and quantification of uncertainties, and of course collecting, storing, and reducing and presenting the data in a context which preserves all of the expert knowledge and rigor that went into the design and execution of the experiment. The next slide Dave has included here, it shows the NE software projects that are referenced in the IRP call and how they are being integrated for high fidelity multiphysics modeling and simulation. The multiphysics code components are shown grouped by code suite along the horizontal axis and by physics focus on the vertical axis. X's and O's indicate ongoing and planned integration efforts to provide high fidelity multiphysics connectivity. So let's move on to the next slide, which lists the key characteristics of a validation experiment taken from the reference publication. As you prepare your proposal, you ought to keep these in mind and see if you can address those. A validation experiment should be jointly designed and executed by those conducting the experiment and those developing the code. So as noted in the IRP call, we anticipate that the applicant would work with the simulation model developer right from the start. The experiment should be designed to capture the relevant physics, all initial and boundary conditions, and any other auxiliary data that the experiment generates or is based on. The experiment should leverage the inherent synergisms that are attainable between experiment and computational approaches. And to the extent possible, independence between computational and experimental results should be maintained. A hierarchy of experimental measurements should be made, which presents an increasing range of computational difficulty. And the experiment should carefully employ uncertainty analysis procedures to delineate and quantify random and correlated bias errors. Now, experimental uncertainty quantification is quite challenging. The quantification of experimental error requires more than simply documenting the calibration of the sensors. As experimental methods provide higher and higher resolution, it becomes increasingly important to fully understand all sources of uncertainty. Now, these include, of course, the instrumentation error, but also the instrumentation bias, repeatability errors, scaling biases, the biases of the person conducting the experiment, and of those who are using the data. We expect the applicant to describe how they plan to address all of these challenges and incorporate them in their methodology for determining experimental uncertainty. Now, this is a slide that I think should be of particular interest to you because we've kind of outlined and emphasized the kind of things that we expect to see in the proposals responding to this IRP. You have to start with a clear application that is of high importance and select an appropriate modeling and simulation strategy and propose a multiphysics validation benchmark based on a new experiment. So you have to explain which gap are you addressing and filling in the available data by the work that you're proposing, and very importantly, explain why the identified gap is considered a higher priority. You have to define a clear approach to uncertainty quantification for the proposed experiment, as well as explain why the strategy that you plan to use is both necessary and sufficient. Similarly, for the quality assurance program and documentation, you must have a clear quality assurance plan for the benchmark to be generated, identify the standards that will be satisfied, and explain why the proposed QA strategy is both necessary and sufficient. And another item that I should have actually put on the slide, which is very important, is that the proposal should contain a well-articulated project plan with credible milestones and deliverables. The desired outcomes from this work would demonstrate a successful approach for high-fidelity multiphysics code validation experiment and benchmark development. This means that an experiment is actually conducted that establishes a benchmark and represents significant advancement in validation of the specific code. Now, there are other calls in the NEAP call that was issued that don't have as broad a scope as we are planning in this IRP. So please look at those and make sure you submit proposals that address all the elements called out for this IRP. The work to be funded under this IRP would add value to the multiphysics code development efforts. It would support establishment of practical methods and guidelines for uncertainty quantification in high-fidelity multiphysics benchmarks, which would support our efforts to establish the Nuclear Energy Knowledge and Validation Center, as well as our activities with OECD NEA in this area. It would also support development of appropriate quality assurance and knowledge management strategies for high-fidelity multiphysics benchmarks by both the center and our activities with OECD NEA. And finally, we expect and hope that this knowledge learned would be incorporated in a course at the college level to advance the state-of-the-art on VVUQ. Well, that concludes my prepared remarks. I look forward to some excellent proposals, and maybe this work will help you get a benchmark named after you. How exciting would that be? All right, with that, any questions that you have, Dave and I would try to answer them.
I am new to this program and am interested in developing new experimental techniques. Is there a mechanism whereby I can find a team to join? Can DOE serve as a go-between between researchers?
That's a question for you.
Yeah, no, we aren't, we don't make the matchmaking. That will have to be up to the, we do have a source book. Where is that, Greg? On NEUP.gov, we have a source book of all of the major players in the university field, but the DOE can't play matchmaker in this case.
So if you use the NEUP.gov search function and search nuclear engineering source book, that is how you can access that document. The next question. Is there interest in development of adjoint methods for uncertainty quantification and coupled criticality and burn-up calculations with high fidelity codes?
So within the NEAMS program, there is interest in development of uncertainty quantification methods for any aspect of reactor or fuel performance simulation, and there is some room for that, for proposals of that type within the NEAMS call, which will be discussed tomorrow, NEAMS 1 call. But I don't know that that would be appropriate for the IRP.
Must the code or multiphysics code system employed be one of those you listed in an earlier slide, or can one develop their own component codes as they wish?
Well, we gave it a lot of thought when we put that language in, and since we've been spending a lot of funds on those specific codes, our first preference in this IRP is focused on picking the codes that are included in the suite of codes that we mentioned in the IRP.
Can the V&V be focused on radiation damage?
I guess again, I'd refer to David on this. If there is a code model that predicts that, and there's a validation experiment that would serve as a benchmark for the prediction from the code, that might be appropriate. David, what do you think?
So I think in a lot of cases that may be acceptable, and in some cases it may not. I think the primary criteria for us would be that we would like to see a benchmark which exercises some of the multi-physics connectivity within the suite of codes that's been developed. So I think it's key to recognize that while some other parts of the call are focused on separate effects experiment development, you know, the key component of this IRP activity, which elevates it to a higher budget and possibly longer time scale, is the focus on strongly coupled phenomena that occur in fuel reactor applications that require some multi-physics treatment in the simulation of those phenomena.
We have a clarification on the containment vessel question. Is benchmarking only for the reactor parts or also containment vessels?
Okay, I believe, correct me if I am wrong, please, Drew, that there is a separate call, part of the call is dedicated to the tools that are developed by the Light Water Reactor Sustainability Program and validation of those components, which would be a more appropriate home for X-core benchmark problem development.
David, at 3 o'clock, the next session is that IRP RC1 call.
Yes.
Where can we find more information about the Methods and Guidelines Committee mentioned in the draft FOA?
Well, that committee is just being formulated. There is nothing yet publicly available that I can refer you to. As I mentioned, that this is something we are trying to establish, and that we're moving forward. But as you proceed with the project, or as you're preparing, I can put you in touch with the right person during the project. But if you have any specific questions on working with them, you can contact me, I guess. Is that okay? Yeah.
Now, just as a reminder, PIs are allowed to contact the federal and technical points of contact in any work scope area before the applications are submitted. At that point, there's no more communication with the federal and technical points of contact. As a follow-on question, is it a possibility that we could potentially include these members in the proposal?
Again, that's an admin question for you, is if there's a conflict of interest or not. I would, depending on the specific situation of the member of the team, it may or may not be within the constraints of the solicitation. Okay. On a case-by-case basis.
Is adding advanced material modeling components to the available codes and proposing V&V considered?
Again, I think we answered that question earlier, that we have a suite of codes that we are trying to expand the regime for which they are validated. So developing your own code and adding a component is not part of this IRP. I suspect, David, you know of other calls within the NEUP where that might be appropriate.
Yeah, well, yes, definitely. Within some constraints, there's interest in the addition of material modeling capability that's called out in the NEAMS 1 component of the NEUP call, which will be discussed tomorrow afternoon.
Are you expecting one experiment or a series of simplified experiments, i.e. each experiment treats only one specific coupling?
I guess we'll have to wait to see what is proposed and see how it advances the goals and objectives stated in this IRP. If you can do more than one multi-physics simulation within the time constraints and the budget limitations, then I don't see why not. David, do you want to add anything to that?
Yeah, I think we, in general, in both NEAMS and CASTLE, we tend to think of validation as a progression of problems and tests that are used to provide some confidence that the appropriate phenomena are captured well by the codes. So I would hope that even in the case where there's one large experiment, there's some progression that provides increasing difficulty. On the slide that outlined the characteristics of a good validation experiment, the need to provide a progression of problems is called out specifically as one of the 6 key characteristics. And I think we would consistently be looking for the ways in which the proposals align with this sort of description of a good quality validation experiment in the review.
Can the experiment take place in another country if that country is willing to pay for the cost of the experiment? From a procedural standpoint, according to the NEUP FOA rules, no federal funding can go to a foreign entity, but you can collaborate with an international institution that's willing to pay for the costs of their collaboration, provided that they are not a denied party or have and observe export control regulations. Can the analytical benchmarks be part of the V&V?
Well, we're looking for a new benchmark experiment, so I don't know what the question, are they referring to legacy